I'll begin the session now. Okay, thanks everyone for coming. I really appreciate us coming to this talk. Let me give you a walk flow of how this talk is going to be. I'll be giving a talk for 30 minutes. Then we'll transition into QA. So before then, if you have any questions, feel free to drop them down in the QA section. When we get to that particular point in the talk, I will try to address all the questions. So let's get started. So this talk is titled Build a Real-Time Database with AWS, a Firebase Alternative. My name is Chibuike Nwachukwu, and I'll be the one giving this talk. About me. Currently, I'm a full-stack engineer at EmailOS. I'm actually a founding engineer at EmailOS. EmailOS is a startup that is focused on email marketing, on content marketing, right? Trying to personalize the content marketing strategy that we kind of have currently, right? We're trying to make it more personalized so that companies can reach out to their prospective clients more efficiently. I also happen to be an AWS community builder, particularly playing in the serverless track. So AWS community builders are people who advocate about the AWS platform, they create content about the AWS platform, and they try to share knowledge, and they share knowledge about the platforms, and then they become community builders. So I'm currently a community builder in my second year. In my free time, I love writing articles, right? So I see technical articles and writing as a way of sharing knowledge and also improving my own knowledge. Due to my constant quest for knowledge, I also take certifications, right? So this year, I think I took around 5 AWS certifications, bringing my certificate number to 7, making me 7x. I am looking forward to getting my 8th certification later this year, which will be my AWS Solution Architect Professional. Right. So outline for this talk. In the first section, we'll be looking at the problem, that is the introduction for this talk. Next, we'll be looking at why DynamoDB, why or what does DynamoDB have to do with this particular talk? How does it solve the problem? In its third section, we'll get to look at AWS IoT and real-time data injection. Then we'll go on to look at AWS Amplify. And lastly, we'll look at a use case that tries to solve the problem the talk is all about, right? We'll see the implementation, and we'll also see a demo. So let's get started. I have this icebreaker from Marisa. She says, with data collection, the sooner the better is always the best answer. This is very true because we live in an age where things or services are meant to occur at real-time speed, right? So you go to a website and you click a button and you expect the page to respond in millisecond, right? So the sooner the better makes clients, makes users very, very happy. So the problem. Let me give a background on why this talk. So earlier this year, a friend of mine reached out to me. He is the engineering manager of his company. He reached out to me because their particular application was communicating with Firebase database. And they were looking to migrate the application from that particular connection down to the AWS cloud platform. So they were looking for a NoSQL database. They needed help to see if AWS had a database that could replicate Firebase Firestore, right? The real-time implementation, the real-time feedback of the Firebase database, could there be a service or a database in AWS that could replicate this? So I sat down with my friend, And at that point, we could not think or get any particular AWS database that could do exactly what we needed to do to simulate the Firebase real-time database. And so this got me thinking. I then went back after I told my friend that I didn't think it was possible to then think how I could actually come up with this particular solution. So the background, like I said, is that trying to migrate their current platform because according to what he said, Firebase was so costly, so they wanted to like handle everything themselves, but they needed it to be AWS cloud. They did their own research and they decided to go with AWS cloud. They needed it to be still NoSQL, and also it should be very, very scalable and also very cost effective. So this drove me to the goal, right? A solution I came up with, which was a use case. So the goal was to have an application or a simulation that will mimic the Firebase real-time database, meaning it should mimic the real-time updates. Also, should allow us to able to make concurrent updates. So what this means is people can be interacting with database at the same time, and we should be seeing results at the same time, right? It should also be very scalable and also be kind of in a lower, not so high in cost, right? A bit low in cost. Also, I didn't want an approach where I had to build everything from scratch. I wanted something that I could quickly build upon, and basically what it meant is just quicker development time. I didn't want to build an approach from scratch. So that's what led me to this particular problem and what led me to this particular solution that this talk is all about. So quick review. Within this talk, you will hear me talk about the serverless framework. So what is the serverless framework? It is an open source platform, or let me say an open source framework that allows us to build and deploy code and to deploy applications as code and also as infrastructure, right? For building serverless applications. It also is also very, very extensible, right? So it allows us to create extensions that extends the base of the open source project, right? So we can create plugins for instance, serverless offline plugins that allows us to text our application offline, right? It supports multiple languages ranging from Java to Node.js, Python, and more. Okay. Yeah. Also, like I've already introduced, talking about Firebase real-time database, which is a cloud-hosted database, right? It's a NoSQL database. Data is stored in JSON and also synchronized in real time to every connected client. So we have multiple clients connected, right? And once a change is made, in particular in DB, it reflects to all clients that are actually looking at that particular data, right? And it scales across multiple devices. So why did I choose to go with AWS Amazon DynamoDB? AWS DynamoDB, I kind of get confused whether it's Amazon or AWS, but you get the point. AWS DynamoDB is a scalable, low latency NoSQL database. So first of all, it had to be NoSQL because they are coming from NoSQL um, database, and also because database is DynamoDB is very, very scalable, right? So this also allowed gave it more points of why it was going to be used. It was ideal for the particular workload they were intending to use because they had multiple users and they needed something that could scale easily, up down easily, right? Also, because of DynamoDB is pay as you go, so you're not having to set up any stuff, any servers or anything. You're only paying for what you use, right? And also supports because it's very, very fast. The more it scales, the more DynamoDB scales, it does not affect the more your workload, let me use that word, it does not affect the response time that you get from DynamoDB, right? So it maintains a single digit millisecond latency, right? And it's very, very flexible in terms of database schema. If you're coming from SQL, whereby you have to design your database, your tables, your columns, and all that, in DynamoDB, it gives you the flexibility whereby it's when you're inserting the data that you can then define the schema schema of that particular data you're inserting. So basically, it's schemaless, right? So you just insert data as you want it. So we have seen why we went with DynamoDB, right? NoSQL scales properly. Also very, very cost effective. So what then is DynamoDB Streams? DynamoDB Streams is an ordered flow of information. So it's what they call a change data capture, whereby any change that happens in the database is captured real time. So what happens is that you have your DynamoDB table. You can then go on to enable streaming so that once there's a change in your database, there is what they call a stream, right? This data capture sends those changes down to a particular trigger that you want to capture that particular change. So just see it as perhaps a tap, right? So DynamoDB is a tap, you on the tap and water flows, right? So that flow of water is DynamoDB streams that sends it down to perhaps a bucket that receives it. I just gave a simple illustration. So a new item is added to a DynamoDB table, which is called a back table in this case. Immediately the data is added or the item is added, DynamoDB streams captures the item and pushes it to a trigger. In this case, the trigger is a Lambda function, which is the publish new back Lambda function. Now you can go on to do whatever you want to do after you get it down to the Lambda function. In this use case, in this example, it sent a message to SNS, right? But in our own presentation for today, we will not be sending to SNS, rather we'll be sending to something else, which we get to see data in this talk. So this is a snapshot of an example from DynamoDB. Currently, the stream is turned on, and as you can see, it's looking for new image. Sorry, it's looking for new images. So basically, what that means is new data that's added to DynamoDB. Right, it's tracking that. If you go down, I went down the page to get a snapshot for trigger to see that we also have triggers. In our case, it's a Lambda function, right? So this Lambda function gets invoked, gets triggered whenever an item is added to DynamoDB, right? So the stream sends it down to this Lambda function. I have an example of the Lambda function. So I clicked on the Lambda function just to show us, and you see that in the diagram, it is attached to DynamoDB, right? So AWS has this fancy way of showing us the connection between services. So we can see DynamoDB is connected to the Lambda function. By the right, we have this particular Lambda function described in the serverless framework YAML file. That is the serverless.yaml file. If you look closely, you will see I have the handler, I have the environment variables I pass to this particular Lambda function, I have the permissions I give the Lambda function, and also attached the stream, right? So it expects to receive data from a particular stream, items from a particular stream. Right. So far we have seen, I've got to know what is DynamoDB. We've also got to see DynamoDB streams in action. And the next point which I want us to look at is we understand how to get the data. We understand how the data moves from DynamoDB down to the streams and down to a particular trigger. So what then happens afterwards, right, is what this particular section of the talk is all about. Real-time data injection and streaming are the heartbeats of modern applications. Currently, we live in an age, which I always like saying, where things are expected to happen seamlessly and as fast as possible. I give an example whereby you click on a button and you expect the result to come fast, as soon as possible, or you are perhaps in your chat application and you're chatting up with your friend, and you don't need to refresh the page. You want your friend message to come below your message, right? Is a social media application. You want the message to come quickly without refreshing. So this is streaming in action. This is also real time, right? So it is the heartbeat of modern applications, right? It drives instant insight and actions for a seamless user experience. So in our own use case, we're moving the data we got to the Lambda function down to AWS IoT Core. So what exactly is AWS IoT Core? AWS IoT Core is a message broker. Basically, it supports multiple clients. Multiple clients can connect to it, um, and then you then have to publish a message to a particular topic. So the clients connect, they listen to a particular topic, and then the publisher just needs to also connect and then send message to that particular topic. So an all connected client that listen to that topic receive the message, right? Highly scalable, integrates seamlessly with other AWS services, and also supports multiple clients. So this is going to be what I call our bridge to other applications, be it third-party applications, to make it or to close out the loop in terms of making it a perfect real-time experience. So this is the example. So the Lambda function publishes a message to an AWS IoT Core. All subscribed devices get this message. So if you recall, we have DynamoDB. Data is being added to DynamoDB. It goes down to DynamoDB streams, which goes down to the Lambda function, which processes the stream and then pushes it down to the AWS IoT Core. I have an example of that process Lambda function I showed earlier. So what does it do? First of all, it watches for specifically for insert events. So for this example, I just wanted to show where I catch only where new items are being created and not perhaps an update, right? So it only looks for an insert. Then I filter it down to only look for when the partition key, that is PK, starts with the word vote. I'm doing this because in the use case, I want to track when votes are added to the table, right? So when users vote, I want to get their results down from DynamoDB down to this Lambda function and down to the IoT Core. Then I process the information, store it in an object, and then publish it to a particular topic called the vote added topic. Right. So when the message goes to the IoT topic, what then happens next? This is where Amplify comes in. So we have seen how what I call the backend works. The backend, in a sense that it moves from DynamoDB down to the stream, down to the Lambda function. All this are happening in the AWS cloud, AWS platform, down to Lambda function, down to IoT Core. So what then happens to the connected clients? How do they interact, or how do they receive these messages in real time? And this is where AWS Amplify comes in. So what exactly is AWS Amplify? AWS Amplify is a full stack app development framework. What it does, or what it's just to summarize what Amplify does, is that it makes it very, very seamless for us to build applications on AWS. It helps down from development even down to hosting, right? It supports CI/CD and also integrates seamlessly with other AWS services. In fact, when I work with anything that has to do with the client side, right, AWS Amplify is my go-to framework for interacting with AWS services from the client side. Super, super helpful whenever I'm working. Right, so we have the application created using AWS Amplify. I used AWS Amplify SDK, if I recall, the library, in the front end to interact with multiple AWS services. Also, I made use of AWS IoT SDK and also an AWS SDK. So basically, these two things were what I used to connect to the IoT Core endpoint. Amplify was used to build multiple parts of the client-side application, but specifically for connecting to the IoT endpoint, I use these two libraries. AWS Cognito Identity Pool, right, was also used to secure this connection. So what I did was the client needs to connect and get real-time data, right? But it needs to connect to the IoT core, right? I want to allow people who are not logged in to still be able to see votes that come in real time. So imagine it as being in a dashboard, right? There's a live dashboard that shows votes. Anybody can just go to their website and see the live results. They don't have to be logged in or authenticated, right? But the people who vote, they need to be authenticated. So I use Cognito Identity Pool to allow unauthenticated users, unauthenticated users to actually connect, right, to the IoT core topic so that they could get real-time data, real-time results as people vote. So this is an example of the client. So the client subscribes after connecting. The client then subscribes to the vote added topic. Then the client listens for messages on that particular topic. So what I just did was, if it's an error, I show, okay, there's an error that happened in the application. But once there's a success, meaning the new vote has come in, the client then updates, right, and updates the UI, adds a new vote has been added, and updates the score for each candidate in that particular election. Right. So let's see this use case in action. The particular use case is what I call face polls. Face poll is an application that allows users to vote using their facial features. So users authenticate with their face. First of all, they go to retrieve their account, register, they authenticate with their face, and then if their records are found in the backend, we use the, Amazon recognition for that. In the backend, then they're allowed to cast their vote securely. Now, all users that are connected should be able to see these votes as they come in, right? So this is mimicking or simulating the Firebase real-time database, whereby once changes are made in the database, all connected clients should see this particular information as they are being changed, right? So this is what we'll be looking at in this particular demo. So this is the full architecture diagram for the voting flow of the application. If you look at it, it has a lot of moving parts, but because of this talk is specifically focused on real-time database, I have a second diagram that removed the unnecessary flows of events and just focuses on what exactly this talk is about. So we have AWS Amplify. So users, the client cast a vote, it goes through API gateway, add a vote, it goes to the Lambda vote, and then verifies that the vote is valid and goes to DynamoDB. Then once the item is added to DynamoDB, the stream gets triggered, right, and pushes it down to a Lambda function. This Lambda function filters the stream and then pushes the message or the item down to AWS IoT Core, which the AWS Amplify client is listening to, and they see the real-time result. So I have a short demo, which I'll be showing us. It's actually a recorded video, so I will mute and then play the video. Yeah, demo time. Right. So I am in the application. So it has, what is going to happen in this demo is I'll be voting on this tab, and we have the live result. We have it open in 2 tabs. I also have the AWS IoT Core. Right, a test environment. In this particular test environment, we'll subscribe. I'll show us that we can actually subscribe. So like I explained, this client currently is subscribed to a topic. You can't hear sound from the recording. That's strange. Okay, so can I play it again, and can you confirm to if you
receive
can hear it?
real-time data that comes in. So the live results are subscribed to a topic called vote added, so that once new results are added,
Can you hear sound now?
the live result without needing to refresh the page, right? Once the user votes,
that's very strange. That's very strange. Okay, so let me stop sharing. Can you hear the sound now? Wow, that's very strange. I'm very sorry about that. I don't know why. I sincerely don't know why. It's not. I don't know why the sound is not working. I kind of very surprised. Yes, so I would let me drop the link to the video. Thanks for that. Let me get the link. Right. There. I'm very sorry for the sounds not playing in the video. But we can actually still just look at the video and try to understand what's going on. So I'm just voting and the result gets showed. I'm so sorry. So we have 2 categories. We have currently there's 2 categories: the FIFA best and the best food. So, and then looking at it, there's another tab. The other tab shows the live results as like live results. So in the first tab, I'll be voting under the FIFA best category for Ronaldo and enter the OTP that I got, like kind of a security token. So once I vote, you're going to see currently the results is only one for Ronaldo and one for Messi, right? But once, as you can see in the video, but once we click on adding for Ronaldo, we get the right results data updated without needing to refresh the page. And not only does it show in the open browsers, it's also, because of AWS IoT Core, allows us to have a test environment, so we could subscribe. So I subscribed to the vote added topic. So immediately the vote was added, this also got the payload, right? So the front end got the payload. There was a vote, they got the result down, and then this particular connected clients. So basically, we have three connected clients. We have the two live results, and then this particular AWS IoT Core test environment also got the results. So that's a summary of what this demo is all about. Voting multiple times and then getting the results real time as they happen. I'm really sorry for the whole sound in the video. I I didn't expect that because I tested everything and it was working fine. I'm not sure why this is happening, but I thank everyone for understanding. So I'll be stopping the demo now because the main point of the demo has been achieved. So I'll be wrapping up. Stop sharing and share. Yeah. So in wrap up, we learned about AWS DynamoDB. We also got to learn about what AWS DynamoDB streams are all about, which allows us to capture changes that happen in DynamoDB real time and then process them or do whatever we want to do with this particular change data, right? We learned about AWS IoT, IoT Core that could be used for data injection, and how we could also connect it with multiple clients. In this case, we worked with an AWS Amplify client to receive the results, to connect to the AWS IoT Core and to receive the result that comes to a particular topic. And lastly, we saw a demo, even if it was not as I expected, that tried to show this real-time simulation happening, whereby users cast their votes and all connected clients also get the results in real time. So I have additional resources. I have the GitHub link for the full open source project. I also wrote an article on it. I'll be copying this if I can. Yes, I'm copying it. I'll paste in the channel on the chat. I also have okay. I also pasted. I think I posted the YouTube channel. Yeah, the YouTube video. Also, yeah. So I'll paste these links in the chat so that we can have access to it. So that's will wrap up this talk. I really grateful for everyone who stayed to the end to listen. I want to know what we learned or if we learned anything new today. Right. So I'm transitioning into QA. So I'm going to look at the questions that we currently have in the QA. So yes, the um, the talk is recorded and the recording will be on the page in about a week time. Yeah. Let me see if there's any other question. I'm just about to copy the link so that I can paste it in the group, in the meeting. Yeah. So these are the links I have in my resources page. So feel free to learn more about the project and also read more about it in the Medium post. We don't have any questions again in the QA. Feel free to ask your questions. I really appreciate them. But if you don't have any other questions, there is no problem. Okay, so I'll give it a minute for that. After that, which I will move on to the next slide. Also, feel free to add your question on the event page in case you perhaps remember a question and the talk is over. You can always, okay, so add your question in the event page. So we have a second question from Kit. How would you start to study for AWS backend if you have graduated a full stack bootcamp? To answer this question, I would say you just have to build. So AWS cloud, as well with anything that has to do with technical, um, I feel real-time practical experience is the best way to like learn, right? So if you want to learn a lot about the AWS and you just came up from bootcamp, you have to go deep into the AWS platform, build some POCs, proof of concepts, test out AWS services, basically get your hands dirty by building um, projects on the AWS cloud, right? And the more you do that, the most established you'll be on AWS, right? How will you start to study for AWS backend? I don't know if I got the question correctly, but I think what you mean is how did you um, start to work with AWS? I guess because you just left the bootcamp. In terms of studying, we have lots of resources. We have the YouTube, we have Udemy, but I always advocate for combining all these resources that are free with hands-on experience, which is like building use cases, proof of concept on AWS cloud. I don't know, Kit, if I answered the question. Yeah, thank you. I think that is it. Yes. Thank you for your question, Kit. So I'm moving on to the next slide if there's no other question. Officially saying thank you for everyone that connected and stayed to the very end. You can connect with me on LinkedIn, Chibuike Nwachukwu, and on GitHub, CHYKE007. I'm not that active on Twitter, but this is also my Twitter handle. The recording for this presentation would be on the event page, I think in a week time. So feel free to go back and watch it. And also I would paste the YouTube link in as a comment on that event page so that we can also look at the um, demo that has sound. Thank you everyone, and thank you Kit, and thank you for having this call and staying for the end of the call. All right, so I've ended the call now.